the last part of your mole concept, you have to count percentage purity, percentage U. Okay, so what does it mean? In real life lab example, the number of moles of products formed is never the theory amount. So this theory amount is all these calculations that you are count. Okay, in the lab, because of laws, right, you have to count what we call the percentage U or percentage purity. Okay, so percentage purity, this is the mass of pure substance divided by mass of impure substance, right? Most of the time you do not have pure substance, right? When you dig up solid from the ground, right? Usually this is a compound, it doesn't exist as element form. Okay, then only the pure parts will react, the impure parts will not react. Okay, so we have to find the percentage purity or your percentage U, which is actual mass divided by your theory mass. So all your calculations, this is 100% without loss, without errors. And then in the lab, when you actually do it, there will be some loss and errors. So this is a small number over a big number. Okay, looking at some examples, it is easier to count. Okay, 100 grams of impure calcium carbonate was reacted with sulfuric acid to form 20 grams of carbon dioxide. Okay, what's the percentage purity? Same idea, step 1, write your balance equation. Okay, step 2, decide. You have 100 grams and 20 grams. Okay, but this 100 grams of carbonate, calcium carbonate, is impure. Means that CaCO3 plus some other things. Okay, so I cannot go and apply mass over molar mass immediately because there's some other things that I'm not very sure what is it. Okay, so now you have this 20 grams carbon dioxide, and this is the amount of carbon dioxide that's formed. Okay, the amount of carbon dioxide formed will be pure. So use these 20 grams to do your mass over molar mass. Alright, so this is your molar mass of carbon dioxide. Okay, so you can count this 0.455 moles. Okay, and then after you count this, use this mole to do the ratio. How do I do the ratio? 1 CO2 is to 1 CaCO3. So the number of moles of calcium carbonate in this case, because it's 1:1, is 0.455 moles. Okay, from this mole, find back your mass. Okay, and this mass is only the pure part. The pure part will react. Okay, so 0.455 times your molar mass. Okay, mole times your molar mass, you get mass. Okay, because mole equals to mass divided by molar mass. So if you do it, you get 45.5 grams. This 45.5 grams is the pure calcium carbonate that reacted with the sulfuric acid to give me CO2 gas. Okay, so the other parts are impure. So I started with 100 grams, but only 45.5 grams is pure. So find the percentage purity, 45.5 divided by 100 times 100%, you get 45.5%. Okay, in the next example, we have your percentage yield example. 100 grams of calcium carbonate reacted with sulfuric acid give me 30 grams of carbon dioxide. So what's the percentage yield? Okay, so over here, let's count it again. First, use this information. Okay, calcium carbonate amount is 100 divided by 40 divided by 12 divided by 16. This is your mass divided by your molar mass. You get 0.999 moles. Okay, again in this ratio is a 1:1 ratio. So you should have 0.999 moles of carbon dioxide formed. Okay, so 0.999 moles of carbon dioxide formed, right? You have the mole, find the mass. Okay, find the mass. So take your mole times your molar mass again, right? So take the mole times your molar mass. Okay, so now I have 0.999 moles. Okay, I try to find the mass, divide by your molar mass of CO2. So carbon is 12 plus 16 plus 16. Okay, 12 plus 16 plus 16 is 44. So mass of CO2 is equals to 0.999 times 44. 43.956 grams. Okay, so what is happening is, right, if I have 100 grams of calcium carbonate, sorry, hold on for a minute. Yeah, if I have 100 grams of calcium carbonate, okay, it should give me 43.956 grams of carbon dioxide gas. Okay, this is in theory, everything that I counted based on these 100 grams, it will give me this. Okay, but instead, it only produced 30 grams based on, in the lab, when I actually do it, there will be losses. Okay, so find the percentage U. So what do I do? Take the mass, right? You can take 43.956 divided by, 30 grams divided by 43.956 times 100. 68.3%, that's your percentage. Okay, you can use the mass to count. In this example, we are using the mass to count, or you can use the mole to count. So if I use the mole to count, this is 30 divided by CO2's molar mass is 0.682 moles, right? And then 0.682 divided by 0.999. 0.999 because the mole is 0.999 that I counted based on 100 grams. Okay, you get it the same answer. This is a rounding error problem. So remember, percentage U is always small number over big number, whereas just now the percentage purity, you cannot count the mole of the impure calcium carbonate. Okay, you have to count it based on whatever that is pure in the question.